Okay, so let's continue on with looking at the different kind of transformation here with the change in the x values. So I'm going to start with y equals x squared again. I'm going to use the same points we used previously, and here they are. The y values are 9, 4, 1, 0, 1, 4, 9. And now I'm going to transform the graph by applying y equals x minus 3 squared. And in your Desmos activity, you may have noticed that when you apply that kind of transformation, you will see a shift in the graph along the horizontal x-axis. So here is y equals x minus 3 squared. Close the bracket first. Squared. And I'm going to also plot the base graph y equals x squared. So you can see that the graph is a shift to the right. Okay, so a minus h value. Remember, we're dealing with equations in vertex form. And equations in vertex form are given as y equals a times x minus h squared plus k. So if you see that minus 3, we're talking about a shift of x values 3 units to the right. So for shifting x values 3 units to the right, I'm going to be adding 3 to every x coordinate. Okay, so don't confuse the equation. Equation has a built-in minus sign. Okay, but what's happening to x coordinates? Well, we are shifting them to the right. We're adding 3 to each x coordinate. So here we have x plus 3. So all of these x coordinates here, I'm going to add 3 to them. So from here to here, I get 0, and then we have 1, 2, 3, 4, 5, and 6. Y coordinates are still the same. So 9, 4, 1, 0, 1, 4, 9. So what if you looked at x plus 4 squared? Okay, same idea. Let's plot this in the graph. So instead of minus 3, I'm going to erase that. I'm going to say plus, plus 4. There we go. And now we see we have a graph shifted to the left 4 units from our base graph. So it's shifted to the left. So it seems counterintuitive to think, oh, plus 4, why is it left? Well, shouldn't that be right? Well, because the form of the equation in vertex form is x minus h squared. So you think of this as x minus negative 4 squared, right? So h is this is h is negative 4, and that's so x minus negative 4 is what gets you the x plus 4 that you see here. So what's happening? Well, to go to the left, I'm subtracting 4 units. That's why h is negative 4, so I'm subtracting 4 units from every x value. So for my base graph, these x coordinates get transformed by subtracting 4. So negative 7, negative 6, negative 5, negative 4, negative 3, negative 2, negative 1. And the y values stay the same. Okay, and you can also plot these points in the graph, and you can draw your graph. I'm just going to illustrate, just use these. I'm just using these Desmos to illustrate them. So here's, put the first graph again. So x minus 3 squared. Okay, and you can plot these 3 graphs in your notes. Okay, so what about the vertex? Well, if you notice, the vertex in the base graph is still going to be 0, 0. That vertex points gets transformed to 3 and 0 for this graph, x minus 3 squared. And then the vertex transforms to negative 4 and 0 for the graph x plus 4 squared. So here, my vertex is 0, 0, 3, 0, negative 4, 0. The axis symmetry, 0, 3, and negative 4. So what do you notice about the x-coordinate of the vertex? Well, the x-coordinate of the vertex matches the x-coordinate, so the 3 and the negative 4 matches the h value that we see in the equation. So here we have an h of 3, and here we have an h of negative 4. Okay. Remember, the minus sign does not count. H is not minus 3. It's going to be positive 3, right? So what value of h goes in here? Well, h would have to be positive 3. And here, this has to be a negative 4. It's the only way you get x minus negative 4 to get x plus 4. So h is negative 4. So that matches exactly with the h in the vertex. Okay, so on the graph, h represents a horizontal translation of 8 units to the right or left. And so this impacts the x values. Okay, so what if we combine them now? Well, I'm going to start with the base graph again. So here are my arbitrary x values, negative 3, negative 2, negative 1, 0, 1, 2, and 3. And its corresponding y values 9, 4, 1, 0, 1, 4, and 9. Now if I transform the graph this time, the base graph into this, x plus 1 squared minus 4, well, I'm going to be, this plus x plus 1 means a shift to the left. So I'm going to be taking every x coordinate and subtracting 1. And I'll take every y coordinate and subtract 4 because k is minus 4. So let's do that. So x is coming over here, so you have negative 4, negative 3, negative 2, negative 1, 0, 1, and 2. And the y values become 9 minus 4, which is 5. Then we have 0, negative 3, negative 4, negative 3, 0, and 5 again. Okay, and if I look at the next one, x minus 2 squared minus 9, well, what's happening? We have a shift to the right by 2 units, so every x value, I'm going to add 2 from the base graph, and every y value, I'm going to subtract 9 because k is minus 9. So from the base graph again, transform the coordinates. So negative 3 plus 2 is negative 1, negative 2 plus 2 is 0, and we have 1, 2, 3, 4, 5. And the y coordinates, you take the 9 and you subtract 9 to get 0. 4 minus 9 is negative 5. And I have negative 8, negative 9, negative 8, negative 5, and 0 again. Okay, so if I plot these points, let's draw the base graph first. So 0, 0, 1, 1, 2, and 4, 3, and 9. Mirror them on the other side. Okay, and there we go. Quick sketch. Let's draw the next one. So I'm going to put this x plus 1 minus 4 by using the coordinates given there. So what's our new vertex? Well, it's negative 1 and negative 4. It's a shift to the left and shift down. All right, so then we have 0, negative 3. And then we have 1 and 0, negative 3 and 0, and 4 and negative 4 and 5, and 2 and 5. So here's our next parabola. So this represents a shift to the left and a shift down 4 units. And the last one here, let's use this rainbow colored marker. So this is a shift 2 to the right and 9 down. So if I plot the points of this parabola, start with the vertex 2 and negative 9, then the surrounding points, and there we go. There's our parabola shifted to the right and shifted down 9 units. Okay, so again, the vertex 0, 0 for the first base graph, transform to negative 1 and negative 4 for the second graph, and 2 and negative 9 for the third. And you can notice something about the vertex. Let's write the axis of symmetries. So negative 1 for this one and 2 for the second one. But again, notice the equations. H is negative 1, k is negative 4. So h is negative 1, k is negative 4. And here, h is positive 2 and k is minus 9. The vertex is positive 2, minus 9. So we can see that from the graph, h and k is my vertex point. And that's it. That is the vertex form translations for horizontal translations and vertical translations. That ends this video.